I work for a company called Chesterton. It's started in 1884. It was basically a rag company. They used to take rags and immerse them in grease and oil and graphite powder, and they sold them to the marine industry because the only thing you really sealed in the 1884 was the stern tube on a ship. It wrapped this rags and grease around there, and as the stern tube went through the ship, it kept the water from coming in too aggressively, but it always leaked. As time went on, they evolved, and it was actually around the time that I came to the company that mechanical packing was starting to be phased out, specifically in the power industry. Condensate water that you heated up and that had been treated, costs money when it goes down the drain and goes to waste. So the mechanical seals started to go into private industry. Now, I don't know where you are with mechanical seals. Do you know much about them? Would it be best if we just kind of started kind of rudimentary and worked our way up a little bit?
Yeah, we've never had them here, we've all been packing.
All right, I'm going to tell you, this is going to be a statement. If you put them in and they didn't work, it had nothing to do with the mechanical seal. Whether you buy a John Crane mechanical seal, or whether you buy a Dermetallic mechanical seal, or you buy a Chesterton. It had to do with the application and a misunderstanding of how to put them in, or not creating the proper environment for them to work. They are everywhere. They're in the washing machine of your house. They're in the water pump of your car. They are everywhere. And they work terrifically. But oftentimes they are sold, especially in an economy where people are trying to make sales now. They are sold sold and represented as an easy bolt-on installation. Everything has to be right up to snuff. And now the way they work is that it's really a very sophisticated application. If you were to, you understand lapping and getting things flat. Do you know what a Johnson block is? Are any of you guys machinists? Okay, if you went to a machine shop and you wanted to see the Johnson blocks, Johnson blocks are two optically flat pieces of metal, and they are lapped to 3 helium light bands. Now, the way that's done is it's done through light. They actually take light and run it through helium. And what you do is when you flash it across whatever surface you're looking at, you can see the grain of it. And to get it to 2 helium light bands, it's a very time-consuming thing. And what you end up with is two blocks that's absolutely, you bring them together like that, they stick. You can't get them apart. The only way to get them apart is to slide them. Okay? A mechanical seal is lapped to 16 helium light bands. And what that'll allow is nothing to leak across it, but it'll allow it to spin on itself. And oftentimes when you want to take the two faces apart, if you're taking a seal apart, you have to slide it off. You'll find it won't want to pop right up, come off that easily. Now, air leaks at 20 helium light bands. So not too far. Air leaks at about 18 helium light bands. So the idea of having dirt on the face of this thing, or it's not going to work. Okay? Now, I'm going to ramble on a little bit. You may have heard this wives' tale that's gone on from, I guess, Adam and Eve, that you're not supposed to put your fingers on the face of a carbon of a mechanical seal. Did you ever hear that? Anybody ever tell you that? Oh, okay. Well, it's good that you're kind of uneducated with it, because somehow or other people have gotten this impression, and I actually had it explained to me that the acid in my fingers was going to eat the carbon on the seal face. Well, carbon is made by God. Only two things in the world eat it up: oleum and fuming nitric acid. Certainly not the oil and the grease in my fingers. So when you're working with these things, if you do touch the carbons, and you get a little grease on it or something, just before you put them together, just take a lint-free cloth and just wipe it and get it clean. It's hard, it's not soft, it'll clean up pretty easily. Well, how it ended up in wastewater was purely a matter of economics. as you probably all know, everything's going out of business. There's fewer and fewer places to work, and the job you chose, oftentimes you realize I'm not gonna get rich doing it, but you're secure, and you're in a business that's gonna be a long time and money's being thrown into it. Well, salespeople like Apollo Lane, jumped on this thing too. As he probably saw industry disappearing in Worcester and going away, he had to, look at other markets, and we started to go after wastewater. And in doing wastewater, it's, in the last 20 years, I would say that every new project that in the areas that I go of, which would be, I'd say eastern Massachusetts, from Springfield all the way to Boston, Deer Island, every one of them, all have Chesterton 442 split mechanical seals, spec'd in from the beginning. And it comes from engineering firms like Kemp, Dresser and McKee and Whitman and Howard. And it's just the acceptable way of doing it. And the reason it's so cool is it's based on the principle of a one part. And this one part has kind of revolutionized our industry. It was patented in 1984, and I wish they had done more with it than just using it in the seal. I don't know what this is, right? But you don't know that. That's a ball and socket O-ring. And the way that works is that if you're used to using O-rings, an O-ring is usually sized, you'll see like a 2-222 or 2-223, and that corresponds over to 2 3/4 or 2.5 inch on the ID. Well, what they do with these is, say that you were looking at a 2.5 inch shaft, and it would normally take say a 222 O-ring. What they do is they take the dimensions of a 223, which is a little larger. And that way, when it's put to get into the groove it goes into, there's just a little bit of compression, and it puts a little effort on that ball and socket, and it seals effectively. So when that thing came around, we had monkeyed before, probably like you guys have used crazy glue on an O-ring, and all the tricks you guys I'm sure know how to do. But the problem is, on a mechanical seal, when you use crazy glue, it gives you a hard spot on the O-ring. And if you're trying to do dynamic sealing, it usually doesn't work out that well. Now, the way let me get a little more evolving. The seals that you tried were an 880 seal. It was probably the only seal that Paul had in his toolbox at the time that would do the job. It was a seal which would be considered a bit old-fashioned today. It was a single piece. You had to take the pump apart to put it in. There was a lot to it. He probably was here, I'm assuming. It was a nuisance. Today, because of the fact that there aren't as many people in plants and nobody wants to pull the pump apart, the split seal has kind of dominated the industry, because you can leave the pump in place, take the seal out, change it. I can guarantee I can do it faster than you can pack a pump. Normal life on the thing is, if all the environmental things are correct, probably 10 to 12 years.
I'll be gone.
I would be until this week. Now I think I'm going to be here a long time. But if you look in the surrounding area here, just quickly, if I go to Webster, all Webster is Chesterton 442 split seals. Go up the street, Wheelabrator is all 442 split seals. The town of Worcester through R.H. White, it's all coming here, is through, all have 442 split seals. If we go down to Grafton, 442 split, they're everywhere. And they're all through there through the efforts of guys like Elaine, bang on doors and slowly converting them over. I think what you currently have absolutely the best setup I have seen. This shouldn't be an issue. You say you've been gone 10 years. I don't think it's going to be an issue for you. I don't think you're ever going to even get involved with it. This was done right. The only thing that will ever cause you a problem, I swear to you, will be another human being. Someone, an operator, anyone will come by and close a valve or do something to screw this thing up, and then you're going to see me. And
All the seal water is plant water. Is that gonna,
No, that's, interesting thing you bring that up. I know your plant water probably gets dirty occasionally, like everybody, you know. The other day I was at a sand and gravel place, and the guy, I had forgotten we had done this. About 7 years ago, he had a pump that pumped a slurry of sand and water, which is abrasive. His biggest problem normally was that it ate through the volute of the pump. It was constantly. So what we ended up doing was 7 or 8 years ago, we epoxy coated the inside of the pump with a ceramic. We put a mechanical seal on it, and it never leaked again, and he never had any more problems. And he was surprised about that. But the interesting thing is, from what you're just saying, the easiest thing to seal is large particulates. The hardest thing to seal in this place is RAS. Because RAS is like puppy poop. It's fine, it's very, very molecularly small, and if the seal were to open for a fraction of a second, just burp. Well, matter of fact, that phone call I got is Warwick, Rhode Island. I have to go there because what actually happened was somebody slammed something shut, and what they think what happened is probably the pump is one of these things, opened it up and they got some RAS in between it and it started leaking. But your plant water, no, it will be fine. And it's a good environmental thing because you're not using city water. I still see plants where they have city water. In the lift stations that all come here, I make them shut the water off because they're all vertical pumps. Gravity's working in my favor, and centrifugal force is working in my favor. Most of the solids want to be thrown to the outside of the volute, and because it's vertical, it's hard for the solids to get up there. Now, occasionally you get rags and things, but we try to, when a place like R.H. White takes the pump, I tell them to take the web out of the bottom of the stuffing box that held the packing in, so I have an open hole there now. And there's much less chance of things getting in there and it flushes out, you know, very easily. Okay, we're going to put the seal together right now. You have the enhanced seal that showed the yellow clips on it. This is an older design. Okay, so now when it comes, specifically to packaging, if you look at how this thing's packaged, you get a feel for how critical a piece of equipment it is. It's got to go through UPS, they're shipped all over the world, they get banged around. Spend a lot of money making sure it doesn't get damaged. It's like an instrument. Do you want to do this?
no, go ahead.
Okay. I'll tell you, in most cases, especially for you, with you guys having brand new seals and new pumps, you most likely won't, it'll be years before you get involved. Unless there's some startup problems where initially we get involved. There could be slag in the pipes, you know, something that makes something happen. What we do is that, let's say it went 4 or 5 years and something happened. You needed someone to come in. You said you may be gone, there may be a change in personnel, and certainly not going to remember today's event. You just call Chesterton, we'll send a guy out here. He'll assist you at no charge to get you through putting it together. Because this is a big investment. The seal that you have with the faces that we have in them, initial cost on is about $1,500 a piece. They're rebuildable for a fraction of that because you don't use the stainless steel. Okay, this is the gland. And the way they make anything that's split is what you do is you split it and then machine it. If you can't make something, split it and then have it be the same size because you lose the cuts. You can get a feel for this thing.
This is about the same size we have out there.
Yeah, same size you have out there, right. This gasket is what seals on the stuffing box face. Now, when you were talking about doing the thing with Paul years ago, it was a packing conversion. So most likely the pump had been leaking for years and the face of the stuffing box was a bit eroded.
Yeah.
And also, it probably was not 90 degrees to the shaft, if you picture what I mean. It's a stuffing box face. At the time, no one cared that it was going to be square. So what should have normally been done is you'd take that off. It would be sent to a machine shop. They would find the square fit on the bottom of the stuffing box, machine that flat, and then you have a better shot. 'Cause otherwise, the seal, every rotation would have to flex. You know, you get a thing called hysteresis, which is a big word which basically means metal fatiguing when it's in a high vibration. The springs would break on it. Now, this seal, these are springs. You know, the seals you normally see, if you do a water pump on your car, you see a big single spring seal. If you do a standard mechanical seal, sometimes you'll see 8 little springs, look like they came out of a ballpoint pen. These are wave springs, and the nice thing about them is engineering has found that there's less chance of that hysteresis with this type of a spring because of the mass of it. You know, it's a big spring. This piece is the only thing you see when you walk down into the pumps. You see this sticking out. This is the rotating arm that they were showing in the drawing. And this is probably the only area that you'll find a little bit difficult when you're putting it. If you get beyond putting the rotary on, that's what's easy. And the only thing that's difficult about putting the rotary on is usually getting your big mitts in the place to put these things.
No room.
Yeah. Although again, the new pumps, you've got probably a foot between the bearing casing and the sounding bar face. You've got some room. Now, you see here the elastomers that they talked about lubricating. Now, you see this, when this particular one is, it comes from the factory, it comes with a split O-ring like that. I like that O-ring. Reason being is that if I were to put the ball and socket one on, that you see, it's an extra item, some pumps I can't see where it is. With this, I know it's already in the holder. I put it together, clamped, and it's done. That's why it's one of choice. There are other people who swear by it and pull that out immediately and put it in. So it becomes a thing of feel. Now, that's a clamp. So let's say that's a 3.5-inch shaft. The clamp is probably, so 3.5 would be your shaft. When this is clamped together, it probably has like a 3.492 clamping dimension. So you'll always see on any clamp a little bit of space between each one. That's how it works. It's an interference fit. So if we were going to build this thing, we don't have a shaft here, but we would put this on the shaft, clamp it together. We were going to use the Y clip on this one because it's the older design. And I don't know if I even have it with me here. Oh, yeah. So we would take this, we'd clamp it together on the shaft. We would have put the lubricant in here and on the rubber, just as you saw in the drawing. And when you're tightening it, the nice thing about a clamp is that you've always been taught never tighten one side more than the other, but you could, especially if it's very awkward for you because, again, it's an interference fit. But ideally, you'd get it snug on either side and then go